Hello again. Today we're going to talk about compound inequalities and interval notation. Sounds a little bit trickier than it actually is, but let's start with compound inequalities and what that means. A compound inequality, like a compound sentence, is basically two inequalities put together. And then interval notation is going to be an easy way to write your solution set, and we'll talk about both of those today. So this is going back to the very first day. It says graph the compound inequality. Basically what you're looking at are all the x's that fall between -2 and 5. If I split this up, I have all the numbers that are less than 5. And if I look at this part, if -2 is less than or equal to x, all my x's are greater than or equal to -2. If you switch the sides, you're going to want to switch the inequality. So basically, any x that is greater than or equal to -2, but also less than 5. But you don't have to separate it like that if you want. You can just put it on your number line. So -2 is equal, so it's one of your solutions. It's going to be a closed circle. X is less than 5. It's not equal to 5, so it's going to be open. And then your solution is anything in between. So any number in there would be a solution. It says list all possible integer solutions. Remember, those are just the whole numbers that are on the number line, no decimals. So -2 is part of the solution because of the equal. -1, 0, 1, 2, 3, and 4. Not 5 though, because it's not shaded. All right, so interval notation is another way to write this. And it's going to look kind of funny, but for something like this, your two endpoints are -2 to 5. Those are your two boundaries. So I'm going to put -2, 5. It's almost going to look like a point. Because it's equal to -2, you're going to put brackets. And if you look at the top and the bottom of a bracket, if you ignore this line, it looks like an equal sign. So if it actually hits that number, it's going to be a bracket. With 5, it doesn't get there. It gets awfully close, so you're going to show a parenthesis around 5. All right, so basically this is another way to list all of your solutions. So those are all the integer solutions. You could also write it like this, where it says it's basically anything between -2 and 5. It includes -2, but doesn't include 5. All right, so basically with interval notation, if you just see less than or greater than, or if you see an open circle, then you're going to use parentheses at that number. So if it never actually equals the number, if it never actually gets there, you're going to use parentheses. If you have greater than or equal to, or less than or equal to, it would be a closed circle on the graph. And we would show that with brackets. And again, I like to think of it, if you look at either bracket, it starts with an equal sign, and then you connect them. So if it's equal to it at some point, then it's going to have brackets. All right, so let's do a couple more examples. Basically, you're looking for all the values that fall between -4 and 0. And notice they're always less than, all right, because you're listing them from least up to greatest. All right, so -4, it is included. And 0 is included because they both have the equal. So at -4, I'm going to have a closed circle. At 0, I'm going to have a closed circle. And I'm going to shade everything in between. So it says list all the possible integer solutions. Again, we typically put them in brackets. If you want, just make a little squiggly line if you have trouble with the brackets. So -4 is an integer that's included. -3, -2, -1, and 0 is included because it's shaded in. All right, now writing using interval notation, your two endpoints. Your starting endpoint on the left is -4, and your end on the right, your right-hand boundary is 0. It's always left than right. Since they're both shaded, they're both equal to that number, so we're going to show that with brackets on both sides. All right, this one's a little different when you write the interval notation when you're looking at a single inequality. So let's graph it. You want to graph all the numbers that are just greater than -2. So I'm going to put an open circle at -2. The numbers that are greater than -2 are this way. All right, so that's not so bad, the graphing part, but the interval notation is where it gets interesting. So your left-hand boundary is -2. It doesn't actually hit -2, so we're going to have a parenthesis there. Does it have a right-hand boundary? No. So we say that it goes to infinity. It goes on forever. So we're actually going to put an infinity in there. And can you actually get to infinity? No. Just like we're going to get awfully close to -2, but not actually get there, so we use parentheses. Anytime it's infinity, we'll also use parentheses. All right, with this one, your numbers are less than or equal to 5, so a closed circle there. Shade all the numbers that are less than. If it helps, you could put the closed circle above and just show. Now this time, your left-hand boundary goes on forever, so this way, it's also infinity, but we're going to put a negative on it. So it goes from -infinity to 5. So in your parentheses, your left-hand side goes first. Can't actually get there, so it's parentheses. My right-hand boundary is 5, and it does get there, so it equals 5. Put a little equal sign to remind us that it's a bracket. All right, so a little bit odd, but not so bad. All right, so we talked a little bit in the last lesson, that last question about and versus or. If it's and, if the x is in between, which we'll look at in just a minute, both parts must be true. So it has to fit both descriptions. If it's or, at least one part must be true. So let's think about this in terms of like a real life situation you can relate to. So if I say I'm going to the mall and the park, that means I'm going to both places, assuming I'm not lying. So, hey, I'm going to go to the mall and the park, so I'm going to go to both places. If I say I'm going to the mall or the park, that means I'm going to one or the other. All right, so as we relate it to an inequality, if I say all your x's have to be less than 3 and they have to be greater than or equal to -4, if I graph that on the number line, let's start with x is less than 3. And I'm not going to shade it all the way. So x is less than 3, and I'm going to shade this way. Just going to start it. And my x's have to be greater than or equal to -4. So closed circle at -4, and I'm shading this way. So basically, you're looking at everything in between there. So it's like what we were doing before. All your x's have to fall between -4 and 3. If I say it's less, the number has to be less than 3, and it also has to be greater than -4, it has to fit both descriptions. So if I want to write that as a single inequality, start with your smallest number to your largest number. All the x's are in between, so I put the x in between. Now all my x's are less than 3. If I put this -4 down here, I'm going to switch it, right? If x is greater than -4, if I'm writing it this way, -4 is less than or equal to x. I know it's kind of confusing, and you're not going to have to do that a lot, but that's how they would write it. And again, it's always less than for those. But if it's an and, it has to fit both descriptions, and you shade in between. If it's or, it's a little different. X can be less than or equal to 1. Or, so any of those would work, or x can be greater than 5. All right, and the nice thing about or, think about rowing a boat. You might say, a boat? think about if you're rowing a boat, those things sticking out that you're paddling with are called oars, right? Spelled a different way, but if you're rowing a boat, so here's the boat, you're rowing the boat, the oars are sticking out. All right, anytime it's an or problem, you may see the shading going out like that. If it's an and problem and the X is in between, you shade in between. Can a number be less than -1 and greater than 5 at the same time? No. Less than -1 would be like 0, -1, -2. Are those also greater than 5? No, there's nothing that fits that description. But if it's or, it could be one or the other, so that does work. All right, so let's write the compound inequality that matches this one. Remember, basically your x's are greater than -3, and they're less than or equal to 2. It's everything in between. So if I flip this one around so that -3 is less than x, and then I put this one next to it, we'll just make it 1. So -3 is less than x, and all my x's are also less than or equal to 2. Kind of tricky, but basically if the x's, or if the shading's in between, your x's in between, all of your x's are greater than -3. So if I put the -3 first, don't forget to switch it around. So -3 is less than your x, and all your x's are less than or equal to 2. So that would be a compound inequality. All the integer solutions, could it be -3? Nope, because it's an open circle. Could be all these decimals, but we don't want the decimals. We want integers. So it starts with -2. That's an interesting looking bracket. -1, 0, 1, and 2 is included. All right, and then interval notation, your boundaries, your left boundary is -3, your right boundary is 2. -3, it doesn't quite get there. It's an open circle, so we use parentheses. But with 2, it equals it, so equals would be a bracket. Okay. We'll save the rest of these for the next lesson. I don't want to make this too long, but we'll get some practice. If you want to get a head start on these, by all means, go ahead. But otherwise, we're just going to focus on writing with interval notation and graphing those. If you have any questions, let me know.